All right. Today's mini lecture is going to deal with drawing Lewis structures. Before we go into today's lecture about how to draw a Lewis structure, let's first go over the three types of bonds. First, we have the ionic bond. We know that that's going to be a metal and a nonmetal. Then we have the molecular bonds or the covalent bonds. That's going to be a nonmetal and a nonmetal. Finally, the metallic bonds, which is a metal and a metal. Well, in today's class, we're looking at only covalent bonds, only those molecular structures. So they have to be a nonmetal and a nonmetal. So what I would like to do is first of all go over what is known as the Lewis structures and what is known as the octet rule, what is known as the duet rule, and then how to go through and actually draw. So the octet rule we know is whenever octo, meaning 8, whenever your atoms can share electrons to get to a more stable state. That more stable state is having 8 valence electrons. That's the octet rule. There are 2 exceptions to the octet rule, and that's going to be the smallest elements on the periodic table. That's going to be our hydrogen atoms and our helium atoms. Both the hydrogen and helium adhere to the duet rule. The duet rule means that they have 2 electrons in their outer shell. Now, if you think about the first shell, it only holds 2 electrons. So hydrogen has 1, so instead of it trying to gain 7, it just gains 1 to get that full outer shell. And helium already has that full outer shell. So what I would like to do is just simply go through and show you how to draw some of these structures. So I've put 4 examples on the board. I put carbon tetrachloride, which is carbon with a chlorine. And if you look, carbon and chlorine both are nonmetals, so that means it has to be a molecular compound. So the very first thing I want to do is I want to go through and I want to add up the total number of valence electrons. So if I look at my periodic table, I know that carbon has 4 valence electrons, and I know that chlorine has 7 valence electrons. So I'm looking for the total valence electrons. So I have 4 chlorines, so that means that's 4 times 7, so that gives me a total of 28 valence electrons contributed by the 4 chlorines and 4 from the carbon. So I end up with valence electrons, and I end up with 28 plus 4, which is 32 electrons. So step number 1, if you look, it says add up the total number of valence electrons. That's what I did, and I wrote it right beside the compound. Step number 2, and this is on the shared screen, it says decide what is the central atom. Which one goes in the center? The easiest way, guys, is the one that occurs least often. You see I have 1 carbon, I have 4 chlorines, so the carbon would be the one in the middle. So I'm going to put, and this is step number 3, says I'm going to hook these particles together using single bonds. The single bonds is 1 dash, represents 2 electrons. So I would put a chlorine here, 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 and here. Guys, normally what we do is we just say we're circling around it north, south, east, and west. And that's what I did. You can see chlorine and surrounding the carbon atoms. So I have just used this. It goes into step number 4. It says subtract the number of electrons used from our total. So each one of these lines represents a single bond, and we know that a single bond has 2 shared electrons. So that's 2, 4, 6, 8. So I'm going to come over here and I'm going to say I've already used 8 of those. So that gives me, or leaves me, with 24 electrons. So 32 minus 8 is 24. The next step says, this is step number 5, or I'm sorry, step number 4, it says subtract the number of electrons used, and then step number 5 says use the leftover electrons, if any, to fill the peripheral octet rule. So now I'm going to say, okay, this chlorine is sharing these 2, so it needs 6 more. 1, 2, 3, 4, 5, 6. So I've used 6. Then this one will also use 6. This one will also use 6. This one will also use 6. Now when I do that, I have 6 plus 6 is 12, plus 6 is 18, plus 6 more is 24. So I've actually used every one of my electrons, and I have none left over. So now I'm just going to go through and make sure everybody is at the octet rule. So first let's look at the chlorines. I've got 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8, 2, 4, 6, 8. All good there. Look at my carbon. 2, 4, 6, 8. So that is going to be the structure for the carbon tetrachloride. Now guys, they're not going to be in a plane. We do it in 3 dimensions. You have to remember you have a Y, an X, and a Z. So if I look at this, this is the structure. So you can see, and I've got a model kit, you can see that the carbon is going to be black, and then the chlorines are going to be green, and they're going to be spaced out as far as they can get from one another, but they're not going to be on the same plane. So this is called a tetrahedral, and a tetrahedral means tetra, meaning 4, like Tetris, 1, 2, 3, 4, 4 peripherals surrounding 1. All right, so I would like to go through and draw the next one for you. So the next is going to be H2O, which is nothing more than water. So I have to count up the number of valence electrons. Hydrogen has 1. I have 2 hydrogens, so that's 2. I also have oxygen. I only have 1 of those, and that's 6. So this time I'm going to get 8. Let me try one more time. My valence electrons is going to equal 8. So I'm going to do the hookup again where I put an oxygen with a hydrogen and a hydrogen. And again, guys, I went back in and I put the oxygen in the center just for the simple reason that it occurs the least often. So let's count up how many we've used so far. We've used 1, 2, 3, 4. So I'm going to subtract it right here. And I'm left with 4 electrons. So now, as I look at this, I say, do I put those 4 around the hydrogens? Do you remember a minute ago I told you that there was a duet rule? Hydrogen only needs those 2. So it's full with that one bond right there. It's sharing 2 electrons. So I have 2 electrons being shared, 2 electrons being shared. So what do I do with these other 4 electrons? I can't put them around hydrogen. Well, that's where step number 6 comes in. It says place any of the leftover electrons around your central. So I'm going to put in the same thing, north, south. And you can see I put 1, 2 on the north, 1, 2, and a pair on the south. So now I'm going to go back in. My hydrogens are at the duet rule. That's good. My oxygen, I have 2, 4, 6, 8. It's at the octet rule. All of that looks good. Now you remember I was telling you about that X and the Y and the Z axis? Well, on this one, what ends up happening is your x-axis becomes the divider between the north and the south, or the top and the bottom. So these hydrogens, normally you'd say, oh, they're probably just going to stick straight out like this. Well, they would, but these electrons are not going to be a pair up here and a pair down there. They're going to be in the northern hemisphere. So you got a pair up here and a pair up here, which push the hydrogens down. So the actual structure, the Lewis structure, is going to look like this. Do you see how they're not straight across? Instead, they're going to be at an angle. And that angle right here forms what is known as water. And this is H2O, and it has 2 lone pairs of electrons at the top, up here and over here. So that pushed everything into the southern or the bottom hemisphere. All right, let's look at one that has an actual charge to it. So step number 1 says when you're adding up your total electrons, you need to make sure that you take into account any ions. So if it's got a positive 1 charge, that means that it has actually lost an electron. So whenever I go back in and I count this, I'm going to put my valence electron is equal to, and then I know that nitrogen on the periodic table has 5 valence electrons. Then I go 6, 7, 8, 9. But since it has a positive charge, then it only has 8 valence electrons. So I'm going to put my nitrogen in the center because it occurs the least often, surrounded by the 4 hydrogens. And then remember, your hydrogens just need to do the duet rule. So I'm going to count the number of electrons used, 2, 4, 6, 8. I used all 8 of those electrons right then, so I have none left over. So let's just see if everybody's good. So I have 2 for this hydrogen, 2 for this hydrogen, 2 for this hydrogen. All the hydrogens are good. How about the nitrogen? 2, 4, 6, 8. Perfect. That is, and since it's an ion, we just put a bracket around it and put a +1 right there. That is going to be the structure. Does that look very similar to this? Absolutely. So if I was to look at the structure of this, it would be very similar. This is my carbon tetrachloride. This is my NH4 positive ion. You can see a little bit different because the hydrogens are a little small, but do they not look exactly the same? Both of them are tetrahedrals. All right, the last one I would like to draw is an NH3. This is just ammonia gas, and I'm going to do the same thing. I'm going to count up valence electrons, and this time I'm going to have 5, 6, 7, 8. So I have 8 valence electrons, no charge, so I didn't have to worry about adding or subtracting. It's just a neutral element, so I just count them up. So again, I'm going to put my N, then I'll put a H here, an H here, and an H here. So I'm going to count up the number of electrons that we use, 2, 4, 6. So that's going to be 6 of these used. So that leaves me with 2 electrons. So my hydrogens are good. That's 2, 4, 2, all the way around the duet rule. So they're good. But now if I look at this, I can see that I still have 2 of these. And those 2 remaining electrons, it says, you always place the leftover ones around your central element. So I'm going to put right here, you see how I had a space for them? Those 2. So I've used these 2 now, leaving me with no electrons unused. So I'm going to go back in and make sure everybody's happy. Everybody's either at the duet or the octet rule. 2, there's 2, there's 2. All the hydrogens are happy. 2, 4, 6, 8. Octet rule for the nitrogen, therefore it's also going to be stable. So what is that going to do? Well, you remember a minute ago talking about the north and the south divided by the x-axis? That's exactly what happens. Instead of having the hydrogens on the same plane as the x-axis, those pair of electrons push it down just a little bit. So what you end up getting is, instead of the hydrogens, and y'all can see this, instead of the hydrogens being on the same plane, they're going to be off the plane just a little bit. Do you see how they're all going to be moved into the southern hemisphere? There'd be 2 electrons up here at the top. So the electrons occupy the northern hemisphere, and then the 3 hydrogens are pushed into, at a small angle. This is called trigonal, trig meaning 3, triangle. 1, 2, 3. And then do you see how it goes down into a base with one top? That is called trigonal pyramidal. So we have a trigonal pyramidal shape. Now, what I wanted to do is I wanted to go over in this first video just the very basics. We're only dealing with how to handle, our electrons, looking at the duet rule and the octet rule. We're only dealing with single bonds, and we do have a couple of them where it is an ion, and a couple of them that have excess number of electrons, so they had to go around the center. So Our next mini lecture is going to look at what happens when you start getting double bonds or triple bonds being formed. That's at 2 or 4 or 3 shared pairs of electrons. So I hope that this has helped you. So this is what you should have learned, just a quick summary. What is a Lewis structure? Number 2, how do you determine the total number of valence electrons? Number 3, from that, how to figure out which one is going to be your central and which atoms are going to be your peripheral. And then finally, how do you place all of those electrons around it so that all of the elements are either at the duet rule or they're at the octet rule. So I hope you had a good, or I hope this helped you with that. Thank you.